That's frame tagging in VLANs. Now, how we can say, or how switches basically decide and forward the frame while the configuration of VLANs is implemented. So to identify the VLAN, a packet is belonging to. So if a switch, or to identify the VLAN a packet is belonging to, if you want the VLAN to, to tell that to which particular VLAN a packet is belonging to, switches use tagging to assign a numerical value to each frame in a network with multiple VLANs. So in order to identify a packet to which particular VLAN this packet belongs to, switches are basically using tagging to assign a numerical value to each frame in a network with multiple VLANs. All right, so that's the main reason of frame tagging. So switches basically understand a frame. If you are having VLANs configured, the multiple VLANs configured in your network, switches understand the packets basically based on tagging. So they assign a numeric value to each frame in a network with multiple VLANs. So each VLAN or each computer on a network will have its own VLAN tag, so that when any particular computer will forward a packet, so the switch will look into the VLAN value, a numeric value which is assigned to it with the VLAN ID, or you can say VLAN value. It's going to define that under which VLAN this particular host is, and then accordingly it will forward the packet to any other computer which is in the same VLAN. If the computer packet or if the device is in the another VLAN, that means it will drop the packet. So this is done to ensure we are using VLAN tagging to ensure that switches ensure that switches know how to reach hosts to forward frames. So for example, I will draw a very simple topology here. We have switch 1 here. This is trunk port. I have switch another here. Okay, that's device here. That's another device here. We have another device here, and we have another device here. So this is switch 1, S1, and this is S2. This is host B, this is C, this is A, and this is D. So this is, for example, VLAN 4. Both the computers are within the VLAN 4, and both the computers are within the VLAN 3, or you can say 1. VLAN 3. So there are 2 VLANs in the topology. which is here, namely VLAN 3 and VLAN 4. So host A, this one, sends a broadcast packet to switch first, which is S1. This host A will send a broadcast packet to switch S1. Switch S1 will receive the packet, and what it will do, it will tag the packet with the VLAN ID of, what's the VLAN ID? 3. So it will receive the packet, this is the packet, and it will add, or it will assign the VLAN ID 3 to it. That's what frame tagging is all about. And it will send it to switch 2. Switch 2 is here. S2 will receive the packet, looks at the VLAN ID. It will receive the packet and it will look at this VLAN ID, which is VLAN 3. And then it will forward the packet only out to the port, for example, FA0/ this one, this access port, because they are in the same VLAN. Since only that port is in VLAN 3, host B and host C will not receive the packet because they are in the different VLAN than host A and host D. Are you understanding? So what the concept of tagging is, if this computer wants to send the packet to this, for example, they will be able to ping each other. This and this will not be able to ping each other. All right, so they are in the same VLAN. So when you try to ping, first this host A will send a packet to switch first. Switch first will receive the packet and it will assign the VLAN ID to it. And then it will forward that packet to S2 through the trunk port, through the trunk ports both ways, and S2 will receive the packet. When S2 will receive the packet, it will see the VLAN ID is 3, and in S2, automatically S2 switch will have the information about VLAN 3. So whatever the computers are there with the VLAN 3, it will just send out that particular packet to that device. That's what VLAN tagging is, or you can say frame tagging is all about. Okay. Are you understanding?
Yes.
So that is frame tagging. That was a theoretical concept. When you will create VLANs, then what will happen between the computers within the same VLAN. So whenever you send any broadcast packet, so switch S1 will receive it, any switch will receive it, it will assign the VLAN ID and then forward the packet to any other switch. And then whatever the switches you're going to send or forward the packet to it, so it's gonna just receive that and it will identify the VLAN ID. And that concept is called as VLAN tagging, or you can say frame tagging. Okay.
Okay.
Next concept is IEEE 802.1Q. IEEE is an International Electrical and Electronics Engineering Institute. They used to give standards for the networks. So it's one of the, what is IEEE 802.1Q? It is one of the VLAN tagging protocols. So as I've told you what tagging is, so IEEE 802.1Q is one of the VLAN tagging protocols supported by Cisco, switches. It is supported by Cisco switches. The standard was created by the IEEE. which is Institute of Electrical and Electronics Engineers. It's the full form of it. So it is an open standard. It is an open standard and can be used on non-Cisco switches also, SWITCHs switches. Always, I do have some typing issues. So to identify which VLAN a frame belongs to, a field is inserted into the frame's header. So whenever this particular host will send a frame to S1, so a field is inserted in the frame's header, which is VLAN ID. But what's that? So the original frame is this. Frame will be destination MAC address, destination MAC, it's a frame, source MAC, then length, LENGTH, type, then there will be data in it, and then there will be FCS, which is basically a checker. But when you use 802.1 Q protocol or frame in VLAN, it will become destination MAC 802.1 Q tag. Then source MAC, then length, or you can say type of packet, then data inside it, and then the FCS, which is nothing but checking this data, whether the data is correct or not. So this is an original frame, and when you use the protocol 802.Q frame, so it's going to add a tag over here. To understand it more, I'm going to give you an example so that we can understand it more accurately. So example, let's say that we have a network of 2 switches and 4 hosts, the same one like I did, like I told you in my previous example, like I draw a figure in my previous example. 4 hosts, host A and host D are in VLAN 2, while host B and C are in VLAN 3. Suppose we have one switch here, another switch here, and this is trunk ports. This is switch S1, this is S2. We have devices here, one device, we have another device here. So this is B, this is C, and this is A, and this is B. And this is in VLAN 3, and this is in VLAN 4, okay? this is VLAN trunking. This is a segment which is called as VLAN trunking, and it's used because VLANs, this switch is having different VLANs, this switch is having different VLANs, and this computer is on different VLAN, and this computer is on different VLAN. Let's say host A sends a broadcast frame to switch 1 over here. So switch 1 will tag the frame by inserting the VLAN ID in the header of the frame before sending the frame to switch 2. So when switch 2 will receive the frame and knows that the frame belongs to VLAN 3, it will send the frame only to the host D, since the host is in VLAN 3, this D. So when the switch, the concept is same, so it's the same concept which I've told you. When the switch will receive the frame, so that's gonna be the original frame, this one. But when switch will receive it, it will add the tag, and that's using the protocol, or that's using the standard 802.1q. It will add the tag 802.1q tag. So it's nothing but it's the VLAN ID that it's going to add, and then only it will forward that packet to switch 2, and switch 2 will recognize it based on that VLAN number, and it will check which port is or which host has been assigned with that VLAN, and it will just send the packet to that particular host, and it will not disturb these two hosts. That's what is the concept behind frame, or you can say frame tagging. Okay, clear?
Yeah, clear.
That's frame tagging and 802.1q. You can say frame tagging protocol or standard. So next concept is inter-switch link. It's also called as ISL, which is now obsolete. It's not used, but you need to get the information about it also. So inter-switch link is another VLAN tagging protocol. I told you, remember one thing, 802.1q is a protocol which is open standard, and other vendors can also use that. But if you talk about this inter-switch link, which is another VLAN tagging protocol, it is Cisco proprietary. It was, or you can say it is Cisco proprietary, which means unlike 802.1q, it can be used only between Cisco switches, right? But it is considered to be deprecated, and newer Cisco switches do not even support it. So ISL works for encapsulating a frame in an ISL header and trailer. So the encapsulated frame remains unchanged. The VLAN ID is included in the ISL header. So simply, instead of adding the tag in between after that destination MAC address, ISL was adding the tag before destination MAC address. That was the only basic difference. So ISL tag was added before the destination MAC, but in IEEE 802.q, we are adding the VLAN ID in, or you can say after the destination MAC address. So it was simply, wait a sec. Like ISL header, and then DMAC, then source MAC, then it was length, then it was data, and also there was one more thing, it was ISL FSC. There was a checker of ISL itself. So in the header and IFC, so but in the header, ISL header, it was aiding the VLAN ID, not in the ISL FCS. It was just checking it. So this was the frame format of inter-switch link. Okay? Clear?
Yes, clear.
So these are the concepts which you need to clear about. Next thing is, if you have to now configure voice VLANs, how do you configure them? Configuring voice VLANs. Voice VLANs is nowadays every particular company is having their telecommunications implemented in their networks, right? With the internet network, right?
Yeah.
Most, corporate networks today use IP telephony. IP telephony means IP-based telephony. This means that the phones are connected to the same network and use the same cabling as other network devices such as workstations or routers or computers are using. Since offices usually have only a single UTP cable to each desk, most of the IP phones today include a small switch that enable you to connect your PC to the phone sitting on your desk, and then connect the phone to the local network. So if you consider, or if you have seen, you have all worked with the companies, you know about the IP telephony. So in the backside of it, there will be two ports. When you talk about the telephone, the commercial telephone at home, have you seen that? Have you seen
Not really.
this one, the phones that we do have in our offices, in my marketing room where I used to sit, there is a phone, right?
Yes.
So that phone I'm talking about, that's IP telephony that has been configured using the IP. In the backside of it, there is two ports. There are two ports in the backside of that. Let me show you. So IP telephony. These.
Ah, yeah. I know
That's
this.
based on IP telephony. So these are called as voice VLANs. Now, if they are connected with the same particular network, like your computers are connected, now for them also, if you have more than 5, 6, or you have 10, 20 IP telephonies, you have one in the marketing. So you want, like, they should be separately with the marketing. In the same way, in IT department, they should be having separate. They should not be able to communicate each other. So we can configure voice VLANs for that also. But this is not the syllabus in your CCNA, but I'm just giving you the information of it. Okay, so IP telephony is Internet Protocol telephony, is a general term for the technologies that use the Internet Protocol's packet switched connection to exchange voice, fax, and other forms of information that have traditionally been carried over the dedicated circuit switch connections. So some switches are having the features that carry out the traffic of both voice and data. Are you understanding?
Yes.
So in every telephone or like this, which I've shown you, there are two UTP ports. One port is connected to the local network, while the other port can be connected to the PC. Are you understanding? So one port will be connected to the local network, like the network port, while the another port can be connected to the PC. So the port on the phone connected to the switch can carry both data and voice. There will be two ports on this IP1 and 2. One port will be connected to the network, which is on the wall, and another will be connected to a PC. That's another part. So the port on the phone connected to the switch, for example, this is switch here, can carry, so this is connected to the switch, which is connected to the internet. This particular port, which is connected to the switch, this will carry the traffic of both data and voice traffic, data for the computer and voice for the phone itself. Are you understanding?
Yes.
This is the phone which is connected to switch, and it's having two ports. One is for internet, another is for voice traffic. So both data and voice traffic can be used. So to enable this, we need to define two VLANs on the switch port. We need to define, to enable this, we need to define, to enable this, we need to define two VLANs on the switch port, on the SWI switch port. First is data VLAN and another is voice VLAN. So what you have to do, you will go to switch, you need to write the commands. Commands are, it's a homework for you. So for example, we have to create VLAN, so we'll create VLAN 10 and another will be VLAN 20. Okay, then you go to interface, whatever it is, for example, fast Ethernet 0/0. For example, this one, which is connected to switch. We will say that switch port mode access, then switch port mode access VLAN, for example, 10, and switch port mode, here it's not mode, it's access only. Instead of access here, we are using, if you have to enable it for voice, we're using switch port mode voice VLAN 20. That's it. So that's how do we configure voice VLANs. We are adding, instead of adding the keyword access, normally we add it for data traffic. But if it's voice traffic, we are using switch port voice VLAN 20. Are you understanding? So this is how do we configure it. On the same port, fast Ethernet 0/0, we are just going to have switch port mode access. Okay, it's access mode. One will be access VLAN 10, which is for data. Another will be voice VLAN 20, which is for voice. That is, we have now created VLAN. So VLAN 5 will be used for data sent by the PC, and VLAN 20 for the IP phone's voice traffic. So we have then placed the port into both VLANs. So the keyword voice indicates that VLAN 10 will be a voice VLAN. So you can even verify that by using show interfaces fast Ethernet 0/0 switch port, and it will give you all the information. Now, this is a homework for all of you. This is a homework for all of you. In Cisco Packet Tracer, don't think that we do not have the PC, the telephony. This is phone, this is VoIP device, this is wireless tablet, smart device. You can add any one, okay? You can add anyone. We have all types of networks here. You do not have to worry. So these are IP phone. You can add an IP phone. You will click on it. You can see these are the ports. These are all the ports which you can use. IP phone power adapter configuration is here. It should be turned on first. Device must be turned on. So there is a port. I forgot how to turn it on. Oh, you need to add the port, this first. Yep. But you need to add this thing first. Something we need to configure first, which I'm forgetting. Yes, here. Yes, yep. It's a cable, and now it's turned on. Yep. So you need to add it, and here is a point. You need to connect it to that. This is a power cable. It's an adapter. You can add it there, and now it's turned on. IP phone graphical. This is here. Configure VLAN. Configuring VLANs. Here you can type it. You can give a call. These are attributes: cost, power source, track, slots, and anything. Configuration. This is setting, global, graphical user interface. Physical is here. So you just do it. This is your homework. What you have to do is you will just add an IP telephony phone, connect one port of with the switch and another port with the computer, and then try to configure VLANs on the switch and try to access them on the same interface, which is here. So on this interface, you have to configure both of them. Okay?
Okay.
Clear?
Yes, clear.
Try to do it at home. You do not have to do anything. You just have to add, I'm going to give you the topology. This is a phone here. This is a computer here. And that's a switch here. Sorry, not a router, it's a switch. So from here to here, from switch to computer. Kalas. Here you need to configure CLI, and then fast Ethernet 0/1 is the port, and you have to configure both VLANs, voice and what? Data. That's the topology. Try to do it at your free time, and I will see you on Monday, inshallah. Until that, bye-bye. See you. Take care. Okay? I will see your work in my next class. Make sure that it's accurate. And even if we will add one more PC here, let's say, you'll be able to know there are no available ports. There is only one, so that's the main reason. So not an issue. So I told you just go through this only, and that's how do we assign or just configure. Voice VLANs, and this is the command, not this one. Where am I? So these are the commands which I have told you. Okay.
Okay.
Let me just, even if you want, I will just copy and paste them in the group also. So this is a homework, try to do it, and if you have any questions, you can ask me. Everything is clear for today. Do you have any questions?
No, everything is clear.
Everything is clear. All right, I'm going to stop the class right now, and I will bid you farewell for today. I'll see you on Monday, inshallah, and we'll go through with the VLAN protocols now. Okay?
Okay, inshallah.
All right, inshallah. See you. Bye-bye. Take care of your health. Stay home and stay safe. Bye.